Hello students, I am Ajay Karmarkar. Before starting video, I would like to tell you something. Please sit with copy pen. If you find somewhere important, pause the video, note it and proceed on. If you find somewhere difficulty, then please write in comment box. I will definitely solve your problem. And along with, please like, share and subscribe my channel that can reach more and more students. Thank you once again. Now here is the question. An ideal gas has specific heat at constant pressure Cp equal to 5R by 2. The gas is kept in a closed vessel of volume 0.0083 meter cube at a temperature of 300 Kelvin and a pressure of 1.6 into 10 raised to power 6 Newton per meter square. An amount of 2.49 into 10 raised to power 4 joule of heat energy is supplied to the gas. Calculate the final temperature and pressure of the gas. In this question, we have given that gas is kept in constant volume. It means delta V is equal to 0. Okay. Now, the first law of thermodynamics state that delta Q is equal to delta U plus delta W. Total energy given to the system that is utilized in two ways. First part, to increase internal energy. Internal energy is that energy which is required to the system to doing work. And then the system doing work, that is delta W. Here delta Q equal to delta U plus P delta V. Here delta V 0. So delta Q equal to delta U. Because when in the case of volume is constant, total energy provided to the system utilizing internal energy and not doing any work. So here delta Q equal to delta U. In the place of delta U, we have substitute N CV delta T. Delta T. Internal energy. Okay, here N is the number of moles, CV is specific heat at constant volume, and delta T is change in temperature. So here we have find out to delta T is equal to delta Q upon N CV. Okay, now as we know that here from ideal gas equation PV equal to nRT, then N can be written as PV by RT. So delta T is equal to delta Q. Now substitute the value of N. What is the value of N? PV and upon RT and CV. Upon reaches to the numerator, then delta T is equal to delta Q RT upon PV and CV. Okay, here we have given Cp equal to 5R by 2. Okay, so we know that Cp minus Cv equal to R from Mayer's formula. And what is the value of given 5R by 2 minus Cv equal to R? Then 5R by 2 minus R equal to Cv. Then it can be written as 3R by 2 Cv. So when Cp is equal to 5R by 2, then Cv becomes 3R by 2. So now substitute this value, all this value. Here delta Q is given. What is delta Q? 2.49 into 10 raised to power 4. R put as it is. Why we have put as it is? Because Cv in the form of R and T is given 300 Kelvin. P pressure is given 1.6 into 10 raised to power 6 and volume is given 0.0083 and what is CV? CV is 3R by 2. Okay. Now delta T is equal to 2.49 into 10 raised to power 4. R cancel out, upon reaches to the numerator. So here into 300 into 2 upon 1.6 into 10 raised to power 6. Here 0.0083 into 3. Okay. Now here 3 cancel out by 300, that is 100 times. Here 1, 2, 3, 4. 10 raised to power 4. Okay. Now this decimal is removed. Again it is 100. So here this 100 cancel out. 83 3s are 249. This decimal removed, and in the place of 10 raised to 4 we have put 10 raised to 5. Okay. Here 2 8s are 60. Now delta T is equal to, here 3 into 10 raised to power 5, 4, that is 9. Here 8 and 10 raised to power 6. Then it becomes delta T is equal to 3 by 8, 10 raised to power 3. It means 3000 upon 8. Then 8 3s are 24, 8 7s are 56, 8 5s are 40. So here delta T is equal to 375. Okay. Now final temperature minus initial temperature means delta T is 375. Here initial temperature is given 300. So final temperature become 375 plus 300, that is 675 Kelvin. Okay, that is the first answer. Clear? Now we have calculate final pressure. Here we have given gas is kept in closed vessel. It means no change in volume, or volume become constant. So therefore from ideal gas equation PV equal to nRT. Then pressure is equal to nRT by V. Here n is constant, here R is constant, and V is also constant. So it can be written as P is directly proportional to the T. It means pressure is directly proportional to the temperature. So it can be written as P2 upon T1 is equal to T2 upon T1. Then P2 is equal to T2 upon T1 into P1. Now substitute all this value. Here T2 we have already find out 675, and T1 that is 300. And what is T1? T1 is given 1.6 into 10 raised to power 6. Okay. Here 20, it means 10 raised to power 2. And subtracted from 6, that become 4. Okay. This decimal is removed. So now again this 4 become 3. It is cancel out. 3 2s are 6, 3 2s are 6, and 3 5s are 15. Then P2 is equal to 2 to 5 into 16. 16 5s are 80. 80 or 8. 16 to the 32. That become 40. And 16 to the again 32. And 4, that is 36. 3600 into 10 raised to power 3. So it can be written as 3.6 into 10 raised to power 3, 4, 5, and 6 Newton per meter square. So this is final pressure. I hope so you understood this question. Thank you for staying till the end of this video. Definitely when you will become success, whole contribution goes to your hard work. But if my videos, my lectures, my questions will help in your success, I will consider myself lucky. Please like, share and subscribe my channel that can reach more and more students. Thank you once again. Take care. Bye bye.